Welcome to 85th lecture. We are studying transient analysis of circuits, and in this lecture we will solve an example where we have this circuit and this switch is open and it remained open unless the circuit achieved steady state, and then it was closed at time t is equal to 0, and we have to find v sub c of t for all times t. In this lecture we will solve half of this problem, and in the next lecture we will solve the remaining part. Right, in this first half we'll solve for the initial and final conditions. Time t is equal to 0 minus the situation, the value of Vc just before we have closed the switch, at time t is equal to 0 plus just after we have closed the switch, and at time t is equal to infinity when the circuit achieves steady state after the switch was closed. So let's start. Let's find the quantity V sub c at time t is equal to 0 when the switch is open and just before it was closed and the circuit has achieved steady state. Right, for that we have to assume a voltage V here, a voltage V1 here, a voltage, let's call it V here, but the circuit has achieved steady state. This means the capacitor has attained a voltage drop across it, the maximum it could, and now it is open circuited. It is completely charged and now it is open circuited. So let's assume a voltage V here and write KCL, Kirchhoff's current law equation, for this node. V minus, there is a 3 ampere current source entering in this node, therefore it will be taken as negative, minus 3 plus V over 4, the current in this branch, this is ground. But the current in this branch is 0 because the capacitor is open circuited and there is no current flow. So therefore this plus 0 is equal to a 0. So V comes out to be 12 volts. This means Vc at 0 minus is 12 volts. The voltage across a capacitor, the voltage, sorry, this is not Vc, this is V. This is V. So Vc is the voltage drop V plus this 24 plus 2Va, where Va is the same as V. So this is 2V. So 24 plus 3V. 24 plus 3V. This is 24 plus 3 times V. V is 12. 3 times 12, so it comes out to be 60 volts. So at time t is equal to 0 minus, just before we have closed the switch, this Vc is 60 volts. What happens at time, this all analysis was at time t is equal to 0 minus. Let's do it for t is equal to 0 plus, just after we have closed the switch. Right. Let's see what the topology of the circuit is after we have closed the switch. Once the switch is closed, this is short circuited. This means the positive and the negative, the upper and the lower ends of this 3 ampere current source, they are now short together. Therefore, this 3 ampere source becomes meaningless. So it can be removed. And this capacitor is replaced with a voltage source. It's a temporary voltage source having magnitude 60 volts. So Vc at 0 plus is the same as it was at 0 minus. This is 60 volts because we already know that the voltage across capacitor cannot change suddenly. Therefore, the voltage across capacitor, it remains the same at time t is equal to 0 plus as it was at time t is equal to 0 minus. So it remains the same. Now let's move on to the final thing that we have to study in this lecture, and that is we have to compute this Vc at time t is equal to infinity. So what is Vc at time t is equal to infinity? As the time goes on, this 60 volt source, it doesn't retain its voltage because it is now charged, because the circuit, the dynamics of the circuits, the topology of the circuit is changed. This 3 ampere current source is no longer in the circuit. Therefore, this voltage drop across capacitor would have been changed. This would be charged again at a new voltage. Let's see what that voltage is. To find that voltage, we will again assume a voltage V here. What's that V? This V, once the capacitor is charged at a new voltage, it will be open circuited again. Once it is open circuited, there is no other source in the circuit. The 3 amperes current source is no more in the circuit. So we have this 24 volt source and this dependent voltage source in the circuit, but they are unable to cause a current flow through this circuit. Why? Because the circuit is open circuited at these 2 points. Therefore, they will not be able to cause any current flow in this circuit. Neither these 2 sources nor that 3 ampere current source that we have removed, because its positive and negative upper and lower ends were short circuited. Right. So in short, there is no current in the circuit. So what is Vc at infinity then? Right. If there is no voltage drop across this 4 ohm resistor, this means if there is no current through this 4 ohm resistors, this means there is no voltage drop across it. So if this is ground, this is also ground, because there is no voltage drop across 4 ohm resistor. Right. What is the voltage here at this dotted point? Let's call it V1. What is V1 then? V1 is the voltage on the positive side of this 24 volts, while its negative side is connected to ground. So V1 has to be 24 volts. So here at this point, we'll have 24 volts voltage compared to ground. And what's about this 2VA? This would be 0 because VA is 0. VA is 0. The voltage drop across 4 ohm resistor is 0. So 2 times 0 is a 0. So there is 0 volt. This voltage source is supplying 0 volts. So 24 plus 0 is 24 volts. So Vc at infinity comes out to be 24 volts. So now we have computed these 3 quantities, that Vc at 0 minus was 60 volts, Vc at 0 plus was also 60 volts, Vc at infinity was computed to be 24 volts. In our next lecture, we will continue solving the same problem and will come up with a general expression for all values of t for this voltage drop across capacitor. That's all for this lecture. Thank you.